So this question gives us a function f of x is negative 3x squared minus 12x plus 7. We want to determine the vertex of the parabola and determine the domain and range of the function, as well as determine whether it achieves the minimum max of something at some x value. So let's take a look at it. F of x is negative 3x squared minus 12x plus 7. This is what we are starting with. And we want to find the vertex. So remember, the x value of the vertex is going to be at negative b over 2a. And our general form, right, is f of x is ax squared plus bx plus c. So if that's the case here, b is negative 12, a is negative 3. So negative b is the negative of negative 12 over 2a over 2 times negative 3. So the x value is 12 over negative 6, which is negative 2. The vertex will occur there. Now, what is the y value that corresponds to that? Well, we've got to plug the negative 2 into the function. So we're going to take a look at the y value will be f of negative 2, which is negative 3 times negative 2 squared minus 12 times negative 2 plus 7. So the y value, which is f of negative 2, is negative 3 times positive 4, negative 12 times negative 2 plus 24 plus 7. What does that give me? The y value, f of negative 2. Negative 12 plus 24 is 12, plus 7 looks like it's 19. So the y value is 19. So if that's the case, then our vertex seems to be at an x value of negative 2 and a y value of 19. Now, what were we supposed to say? What were we supposed to answer? We want the domain and range of the function. We have the vertex. Fine. How about domain and range? Well, the fact that this is a negative gives us our idea in that the graph must be opening in a downwards way. So a is negative. If we have a quadratic function whose leading term is negative, we know it's going to be like that. So if that's our situation and this is negative 219, what's our domain, what's our range? So we know this is the way that it's headed. So our domain will be all reals. Or if you like, you could say negative infinity to infinity. About the range, well, it goes as low as you want and it goes up to 19. So negative numbers way down here, negative infinity to 19 with the square bracket because it actually gets there. And then what do we say about our function? It achieves a relative what? It achieves a relative maximum. So looking at this, we can say f achieves a relative maximum or a local maximum. A max of what? Of 19 at x equals negative 2. Now, this can all be verified on the graphing calculator, so let's take a look at that. So make sure you're in function mode, and I am. Go to y equals, and we're going to go with negative. The negative button is down here, negative 3. X squared minus 12x, minus button is here, minus 12x plus 7. Now, you may want to start with zoom standard first, but you'll notice that's not going to go high enough. Let me make the point here. Here is zoom standard. From our pencil and paper work, we think the maximum occurs at 19, so I'm going to need to adjust my window. So my y maximum of 10 is not nearly enough. Let's go ahead and change the y maximum to something larger than 19, just so we can see it. Maybe 25 would be good. And then hit graph. Let's talk about the domain and the range first. Domain indeed is all real numbers. Range from negative infinity up into that point, which we hope is 19. Then how do we find the vertex on the graphing calculator? Second calc, maximum, which is number 4. Left bound, move the cursor a little bit to the left of the highest point. And hit enter. Right bound, move the cursor a little bit to the right of the highest point. And hit enter, and then move it close. Hit enter, and it'll give us our maximum value. So maximum occurs at x equals negative 1.999999. Of course, that's supposed to be negative 2 with a maximum y value of 19. So that reinforces what we did on paper regarding our vertex, regarding our domain and range, as well as regarding the fact that it's a maximum at that value.